Alright troops, Yoker Uni presents Physics.
Right yous lot, I want to sneak this wee cheeky video in before your higher exam, because I've pure had a look at the exam for 2012 and I can tell yous that it's pure got questions on projectile motion and equations of motion. Keep it hush hush. So here's a wee mad video on equations of motion, which is what you have to heavy use to answer your projectile questions. Right, so I've got a t-shirt that says on the front, all you need to teach physics, ... and on the back it says ... it's two balls in a slinky. That's how the Valdo rolls, by the way. Let's get ripped into the equations of motion using balls. But just remember, when I say ball or balls, I could just as well be saying motor or motors, brick or bricks, or mad rocket and mad rockets. You need to know how projectiles behave horizontally and vertically. Horizontally, balls have zero acceleration. Whatever your velocity is horizontally at the start, it's going to stay at this value horizontally for the whole time the ball is moving. Vertically, you have two options. One, a ball is dropped for a height down the way. It accelerates down because of gravity, which for higher is pure 9.8 to the metre per second squared. If you drop a ball, then the initial velocity is 0 metres a second. Option 2, a ball is launched straight up the way. It slows down going up to a maximum height, pure called the mad apex. At the mad apex, the vertical velocity is 0 metres a second. It then drops down for the apex in the exact same way as dropping a ball for that height. So that's all you need to know for projectile motion. These three mad movements, the horizontal motion and the two verticals. Because you're farting about with your mad vectors and crap, you need to keep a heavy edge on the directions. Up and right are positive and down and left are negative. That's what I would do, but it's up to you as long as you don't mix them up halfway through a question, know what I mean? If I stick to my mad method, then gravity will actually be negative 9.8 to the metres per second squared, alright? One more thing before we pure tan the equations is, how do you split up a mad vector into your mad horizontal and vertical components? And it's these mad components that you need to heavy use for your equations. If you don't use them, you need a good slap, you're dafty, alright? Use your components. For projectile motion, you will get an initial vector for the initial velocity and what angle it's pure off the ground at. An easy way to remember comes from one of my mad students called Mick, and it goes like this. The horizontal component is pure given to you by doing cos theta times the vector. That's because if you stick the h for horizontal after cos, then it makes a word, cos, which is, you know, a word in that. If you try to use sin theta for the horizontal thing, then you would get a word called sin, which isn't a word, right? Cos is a word, so that's why we use cos and no sin, you know what I mean? The sin theta times the vector gives you the vertical component. So let's tan the equations of motion. Equation 1 is pure rearranged for acceleration equation. A equals v minus u over t. To give you v equals u plus at. Done! Equation 2 is pure given when you plot a velocity time graph for a ball going travelling at a constant acceleration like this one here. Remember, the areas underneath a velocity time graph gives you the displacement. So the areas add up to give you s equals ut plus a half at squared. Done! Equation 3 is pure go in a mental way, but it works out to give you this one here. V squared equals u squared plus 2as. There's heavy actual a fourth one, but I don't use it because, you know, it's a bit crap. But it's s equals u plus v times t all over 2. Never used it in my life, big chap. So how do you use these then? Well, let's pure figure out the two types of projectile motions then. Things you need to heavy remember is you have to keep your horizontal and vertical motions pure separate. The only thing they have in common is time for things to happen, alright? First motion is when something's fired off a high cliff or a plane in a horizontal direction. This one's pure simple fish easy, by the way. The horizontal motion is just a constant velocity, which you can use the old timer equation with distance, speed and time, only we need to pure use vectors and that. So it's s equals ut. The horizontal velocity is the velocity it fires off the thing at. Or if it's dropped for a plane or something, it's the same horizontal velocity as the plane, you know what I mean? Vertical motion for this projectile is just the same as if you dropped something for that height it started for. It's going to accelerate from 0 or rest down cause of gravity. You can use any of your mad equations of motion depending on what you need to work out. The second motion is a bit more complicated. It's like when you fire something off the ground at an angle, you need to figure out the horizontal and vertical components first, then use them for the separate bits of motion, right? Horizontal is just your mad S equals ut again, because you've got no acceleration horizontally. Vertically is just as easy though, right? It's just the same as if you chucked something up and then caught it again on the way down. With this motion you've got the components, then you can fart about with your equations of motion to get the answers you need. Let's get ripped into some proper examinational questions then for the old SQA and that. This one here is a pure doddle. Even Deco, who once lost a game of noticing crosses to his own dog, could do it, by the way. It's that easy. That's the level of easiness we're talking about. This question is multiple choice. These questions are sneaky wee basses, by the way, because they've got one right answer and 4 wrong ones. The wrong ones can pure confuse.com the hell at you, so my advice is cover them all up first and do your working, and then uncover your answer and see if yours is there. Obviously though, if the answer isn't there, then you've got a problem, so do your sums again and double check it. This question's pure asking you to figure out how much horizontal speed you need to make the jump. First thing is to figure out the time for the whole flight. You can figure out the time if you work out how long it takes something to drop 2 metres cause of gravity. The mass isn't important and we can just ignore air resistance here, alright. So this is how you lay out your working and put down in your working what you know first. Some botting called this suvat. I don't, but knock yourself out big chap if you want to use it. Vertically speaking, you know the displacement down is minus 2 metres. The initial vertical velocity is 0 metre a second. We don't know the final velocity, we might not need to know it, but let's move on. Acceleration is minus 9.8 metres a second squared, and we need the time. So what we know is, we know the S, the U, the A, and we need to work out the T. Figure out what equation matches all that stuff, and for this one it's equation 2. Here's a mad working, and you get your time as pure 0.64 seconds. If you need to cover a distance, a horizontal displacement of 5.1 metres and a time of 0.64 seconds, then your mad horizontal velocity has to be 5.1 divided by 0.64, which is pure 7.97 metres a second. Uncover your answers, big chap. Oh no, my answer isn't there. Think about it though, wee man, think about it. We just did some rounding and crap to get our answer of 7.97, so it's going to be answer D, which is 8.0 metres a second, isn't it? Just keep a heavy edgy on what you're rounding up and crap, alright, and figure out what your answer's going to be. Let's do one more belter, an SQA question then. This is about some mad netball player or something, right? Part A is easy, man, right? Working out your mad components, say the velocity vector, which is your mad cost thing, remember that? Here's your components. Next question says, show the time for the ball to reach the basket is 6.9 seconds. This means you need to show your work in your body and don't just write down 6.9 seconds and hope they give you the marks for it, because that would be daft, and you'd be a dafty. Because you know the horizontal velocity and the horizontal displacement, you can work out the time. Simples. Next bit's a bit more dodgy though. It says you need to figure out how high above the ground the basket is. Now we need to only think about the vertical motion, remember. This is the same as chucking a ball straight up, reaching the apex and then falling back down, but only falling down a bit of the distance. Let's just hit this with one equation then. Then you need to figure out the displacement to the apex, the time to the apex, then displacement back down to the remainder of the time and all that crap, right? No, just hit it with equation 2 and work out the vertical displacement. It should be positive, remember, because it's going to be above the starting height. There's a working there. Add on the vertical height of 2.3 metres that the ball actually started for, and you got your answer H for the basket above the ground. Last bit is one of the wee explanation question things. You're on your own for that, big chap. 2 hints though, don't write down the answer is, because it is, and always try to use an equation to back up your arguments. Capiche? Sometimes you'll get a wee sneaky question about things moving horizontally, like motors and that are pure accelerating. Nothing but gravity here, just use your equations of motion horizontally and go with the flow. Here's one last wee question then to show you this in action, and there's the answer. This stuff is actual easy as long as you remember my rules. By the way, if I ask you to work out the real velocity of a projectile at any point in its flight, just add the horizontal and vertical bits back together in a triangle and whack up the Pythagoras and the trigonometricals. Good luck in your exams, big chaps and big chapettes. Catchy Versace.